So, okay guys, today I'm gonna tell you how you can do undersampling and oversampling. So, oversampling is just like repeating the number of records the times you want and nothing else. And in undersampling, you just decreasing the number of times the record. Is the record which are oversampled or undersampled are same. Nothing is changed. Like if it has four as a digit, so that the undersampled or the oversampled will also have the 4. And in SMOTE, the data is oversampled or undersampled with different techniques, so the data points are nearer to them. So it's uh, most of the time it's good in the classification times task as compared to undersampling and oversampling. So we'll just see. Okay, so we'll just use a Kaggle credit card data set. You can just download it. That's really easy. Okay. Import. Sorry. Panda. Yes. Importing Panda. Get pd. Okay. This is our data set. It's getting loaded because it's very big. I think around 160 MB. Like if you unzip it after downloading. Okay. These are the data sets, and this is the class. Like 0 is a no fraud and 1 is fraud. So this is the class is the dependent variable. Now we'll just look the shape of the class, like value count of the class here. Dot value. Sorry. Yeah, so you can see it's very hugely imbalanced, like 22 lakh 84,000 eight zeros and only 492 is one. So obviously it will more biased towards zero. So that's why we'll do undersampling and oversampling techniques. So let's get started. So let's just get the class in y and x on all the other variable in x, like how we do in normal machine learning tasks. In this we are taking the all the values in x apart from class, all the independent, and the dependent values class is in the y variable. Okay, so we'll like first, okay, just run it. Now we'll from okay learn dot, we'll use logistic regressions to showcase our demo. So you can just, it's really easy, so you can just grab it easily. Okay, just copy it. I don't know what's showing. We are importing accuracy score to check the accuracy, confusion matrix to check the classification done by the R classifier, and classification report. We are using classification report for to check recall and precision and FN score. So yeah, now we'll just import train test split. Okay, let's import it. Yeah, imported. Now we'll just do the train test split. So we, yeah, and let's copy it. Yeah, oh, right, so much. Like I'm taking train size 25%. Okay, yeah. So just make a logistic regression instance. Okay, yeah. Now we'll just lr dot fit next train, comma. Let me just write it so you'll just understand it better. Okay, now we'll just print it. No, no, no. Let's just first test it. Prediction is equal to lr dot predict. Now we are predicting after. I don't know what's happening. It's just really. Now we'll just print the accuracy score. After this, like it will be all copy paste just for a few minutes. It will. I have to write something. Uh, I have to also write like confusion matrix. Okay, let it be just write classification report. Yeah. Hope nothing goes wrong. Yeah. Okay. So you can say it's 99%. I mean, seriously, I haven't done anything, and even using just a logistic regression for such a big data, and it's giving me like 99%. So you can see precision and recall. So precision is recall is nothing like you can say recall is just the percentage of in a layman term. It's not actual its meaning. So recall, you can say the percentage of values it has predicted correctly of that particular class. Like of 0 it's 100%, and for once is like 0.64%. I told you na, like without precision and recall you just can't do anything. And this you can say like the wrong prediction it has done for once, or you can say like basically you have to make all these to one so it will just work better. Okay, these are four values, so let's just do it. So that's why we will use tint go oversampling and undersampling. Okay, yeah. So if you have to like install some library, you can just install pip install imb learn. Like this will the only library we'll be using. So yeah, from imb learn dot near miss. I think it's near miss or what. Okay, so dot undersampling import. Yeah, this is the. So we are importing the near miss, which will just decrease the number of values that will be defined. So ns equals to, let's just take it around 80%. Like you'll know how to use these values like 0.8 to 0.0 to 0.1.0. It's all about 1 to 100%. So we'll just say x underscore train comma ns comma y underscore train comma ns equals to ns dot fit underscore sample comma x underscore train, and let me see for small y or big y. Yeah, small y underscore train. Yeah, so yeah, that's it. And now we'll just print like we'll just use like train values only for now. Train on this, I'll just tell you what happening. Okay, yeah. Okay, I'm printing like the original train value counts, like how much it was previous 0 and 1 values, and like afterwards we are training in and storing it y train ns and x train ns. So I'm printing y train ns values, how much zeros and ones are there after decreasing the size. Yeah, now we'll just copy all of this. Yeah, I told you now, like afterward is just copy and paste. So let me just first check it. Okay, you can see like from 71098 it has came down to 128. One thing, make sure don't use undersampling, because you are losing a lots of data. I mean, you have like lost about like about 71,000 or 70,000 of rows. So never use undersampling. Oversampling and SMOTE are better, but it depends case to case. But yeah, undersampling doesn't good as compared to oversampling. Okay, now we'll just make underscore ns underscore ns. Yeah, yeah, like x train and y train, and it's like these are the less values. Okay, let's just train it. Yeah, see the value have came to 87%, but see recall has increased to 94. Like previously it was 64, because like my model is not much biased toward the zero value, which was very more before. Yeah, so but see, it has gone to 0.01. Hopefully if you will use like random forest classifier or something better model, or just do the hyperparameter tuning, so it will just come around like 80 to 81%. Yeah, I have tested it before, so I'm just telling you. For the like demo purchase, I've only used logistic regression. Yeah, now we'll just let's just come to like oversampling. Yeah, okay, so it's also like from imb learn dot oversampling import random over. You can just change these values, and these will change automatically, like about 80%, like whatever percentage you choose. Yeah, now we'll just do ns equals to, okay, we'll also take it like 0.8 only. And yeah, now just copy these values. So here also we are telling them like about 80%, and just then fitting x train and y train original, then inserting x train and y train in its values into x train ns, and just like printing the value counts. So let's just see what happens. So see, like from 10 to it has came to 56,000. Really incredible job. Yeah, now just copy and just like see how it perform. Okay, it's training. Actually, if I have used random first classifier, so it has taken much time, but the accuracy will be very high. Yeah, so see, accuracy increased to 95%, and it precision also increased from 0.01 to 0.04. Yeah, don't get on the like these values. These are just for demo person. Main purpose is like how tell you how to do oversampling and undersampling. Now let's just come to SMOTE. SMOTE, sorry, I just don't know what it's called even. From imb learn dot combine import. Say it's called SMOTE. Yeah, correct me if I'm wrong, and we'll just copy this. Here also we'll like use about 0.8% of values, and copy this also. So what SMOTEC does, like it's also increases the lower class values, and also decreases the upper class values. Which are more it decreases, and which are less it increases. Yeah, you'll see this. And the best see difference between undersampling, oversampling, and SMOTEC is that SMOTEC doesn't copy the values like undersampling and oversampling does. SMOTEC uses some algorithms and creates a points near to that point. So it's much more good than the undersampling and oversampling. See, like it has reduced 71098 to 70330, and increased 102 to 56110. So yeah, that's the basic functionality of that. Now just let train and test it. You can do like I haven't done grid search CV and K4 like I'm just telling you the basic stuff. See, now it says accuracy and precision has increased to 0.11, And yeah, it's basically, and if you are confused with f1 score, like f1 score is like just a mean of these values, so it never gets more confused with that. It's just actually it's also called confusion matrix because it creates so much of confusions. So this was it, like undersampling, oversampling, and SMOTE. Let me just tell you one thing more, like if your data is very much imbalanced, so you can use class weight in assembler like random forest classifier, like in which assembling techniques are used, because we can assign weights on that, like give 100 times more priority to 0 than to 1. So you can just google it, like class weight for a random forest classifier. It's easy, but it kinda doesn't work good. I have seen, yeah, applied, but it hasn't responded well. But yeah, it's a thing. Sometimes it does. And yeah, basic. This is the only thing. And yeah, so try to use SMOTEC and don't do undersampling, because yeah, use all the three types. See in which one you get the good result, and you'll just use it. Yeah, thanks.